We are working on an EK2300 Elna knit craft, and it came here because this tower was frozen. Now obviously we have solved that problem.
The company calls these drums, Jack calls them towers.
Right. Okay, the drums, upper and lower drum, make a tower in my mind. But yeah, I went into both of them, pulled tons and tons of crud out from under them. That's what always makes them lock up. Now here's why. This is a two-part video, inside and outside, but this is a carriage. Unfortunately, we don't have every bed in the world, and so we haven't got a bed to try this carriage on. Now, it was supposedly knitting except for these drums being frozen up. And this was also the base of the row counter was broken off. But we also have a friend that asked for a spring video, but we don't have a carriage to match his. So I want to point out something for the benefit of those in that same situation. He says he has a flipper on one side that seems to be spring-loaded and one on the other side that isn't, and he's trying to get it back.
May I interject something?
Yeah.
Flippers are what we see moving underneath when we have the cover on.
Right.
Those are flippers. Right.
And he's right. They should be spring-loaded on both sides. If one is spring-loaded,
one is, both should be.
Both should be. Right. Now, see, these swing freely. Okay. And what we're talking about here is bench checking a machine. There again, see, on this side, those flip, and on this side, those same ones. So you need
to examine it closely for symmetry.
Right.
And then it should be the same on both sides. The behavior should be the same.
Yes, with the cover off. Notice we have a type of spring right here that's a rigid coil spring, and what that's called is a shaft spring. See how it's coiled around the shaft? And both ends are anchored somewhere to let it spring load and lift right there. You can see the spring in action. That's one type of spring. Here's another type of spring right here. Is a coiled spring, and you see how it works. It's called a retracting spring. So anytime your carriage isn't working right and you see a flipper, the most noticeable thing is it'll knit going one direction and it won't knit going the other direction.
Or it may catch loops or fail to catch loops or whatever you're telling it. It says one way, but not the other.
One way. And see here again, here's another spring load on one side, spring load on the other side. You can't see those springs, right? Where are the springs? They're not like these. It's a shaft-loaded spring underneath there. On the shaft that this pivots on is a spring.
Oh, so that the clue is if this feels like it's spring-loaded and you can't see a spring,
right? You don't see
wherever that's pivoting is where the spring and where we would look.
This is why I use this example. See how that spring is coiled around the shaft, and you don't see it when the cover's on, and yet every time you do that, boing, up it goes. And that is very common underneath here for this type of flipper. Now this one has a spring on the top, but on many brother machines, the spring is coiled around the shaft underneath here. This is your stitch path to change the stitch size.
Let me move the camera because all I was getting was your knuckles.
There's the stitch path, and this changes to change the tension on the stitches.
I'm going to show them the cover.
Right.
These are the settings that change the stitch path.
This is your stitch dial and changes the size of your stitch, and this dial moves these two arms right here.
But the various settings, tuck, slip, stockinette, and punch lace, and knit in, when you move the lever to those settings, something changes under here, telling the needles where to go.
And we're going to go into that on the second part of the video. I'm going to put it back together to make sure in each function, each one of these levers moves according to what it should. See, here are your two drive cams right here, top and bottom, that push these levers, top and bottom. And so what we're going to do is assemble this and make sure that as it goes into its different positions, that these are moving properly and symmetrically moving the flippers for what we want it to do.
One main reason for this video is Jack wanted you to understand when he says he can bench check something, but I can't knit test it, this is a bench check.
Right, this is a bench check. I will go through every function of the carriage and make sure it is moving smoothly. It does enter each phase. Now, our dial says stockinette, and we've already looked at our flippers to see that, yeah, they're all spring-loaded that are supposed to be, moving freely. Now, we're changing settings. Notice I got movement over here on both sides.
And they're the same. That looks good.
And I've got a little bit of movement at the bottom. Oops, there we go again.
Jack's going into tuck, slip, knit in those various settings.
That's knit in. And this is what I was saying earlier. This, 2 arms, watch how they're changing the size of the path. Therefore, they're changing the tension on the stitch.
Actually, it's lengthening the path so that more yarn is used at stitch size 10 than stitch size 1 or 2.
Right. And they should move evenly and smoothly. Notice the slotted area. If you're doing your own lubrication, run your dial all the way to one end, and this is where you spray your silicone liberally, and then run your dial the other way. And you see, you want to keep these slides moving smoothly because there's very little
Otherwise,
room.
If you've ever had your stitch dial apparently not doing anything, it can be because it's failing to respond because it's gummed up.
And it's also this flipper and this flipper. Look what happens if one sticks and doesn't pop back down. That's where you get it knits fine in one direction because it'll let the butt of the needle slip.
And the trickiest thing to find for me, I've had it happen several times, is if I flip it, it does come back, but not as quickly as the other one. So then you have to have a very educated eye to say, oh, they're not the same.
All right, now listen. That's how you tell. Listen to it.
If they've lifted the same amount, the time should be the same.
Yes, the elapsed time from release to the click is what you want to do.
It takes an educated listener.
But here we go. We're going to go through the dial. We're knit in. Next position says punch lace, and you'll notice that was our movement right in here, this area. Okay, now back to stockinette. Now slip. Look what we've done. We've changed our needle path completely. So now it is not going up in here at all.
Well, what happens
and there's your tuck.
Is that the needles in these various different settings, they'll come out different amounts, different distances as directed to do so. So some will go in one path and some will go in the other. That's what causes slipping versus tucking versus plain old knitting.
And then, of course, you've got settings over here that do the same thing. Where does the needle come in at? Not necessarily on this machine. I don't want to speak out of turn. But on many machines.
Usually this is telling it whether it should knit back from E position or hold, which is we also call hold position.
Right. See, now here's where your needle's going in, but if this is down, this is where your needle's going in.
But that means that any needles that are all that far out won't go.
Oh my, that's
a nice
stiff.
smooth.
So stiff. And it never fails. The one that comes in that isn't working correctly, when I clean them both, it's the faster one.
Isn't that weird?
Strange.
But they both need to be fast and move freely, and they do. Right. Well, I can't do it with one hand and hold the camera with the other.
Well, we're not as smooth as we should be, but I think it's because it was touching the deck.
Oh, it was touching the deck. Right, yeah, that's what it was, because I heard it spin when... There, yes.
But now, this is our settings, and you can see everything is moving symmetrically, evenly, and it's... I mean, that dial, I'm not...
Jack's doing it quickly for you here, but he spends a little time on this. It not only needs to move freely and take its position, occasionally it happens that it'll take the position but won't click firmly and stay there.
Yeah, now listen.
Yeah.
That's what we're after. You see, it'll stop right there.
Uh-huh.
That's not good. But when you hear them click like that, that means everybody's moving like they should. There you go.
It's looking good.
Nice firm movements. Everything's symmetrical. I think it's ready to go home.